All right, the next problem that we're going to do is problem number 10 from the review assignment, problem 10. All right, so let's read. It says the radius r of a sphere is increasing at a constant rate of 0.04 centimeters per second. And you're given v equals 4/3 pi r cubed. Now, A says, at the time when the radius of the sphere is 10 centimeters, what is the rate of increase of its volume? All right, so if we think about a picture, here's a sphere, all right, and it has a particular radius, which is changing, so we have a dr dt. Now, we are told that the radius of the sphere is increasing at a constant rate, so that would be 0.04 centimeters per second, and it is positive because it is increasing. And then we also have the volume, which is changing at a rate dv dt, which we do not know. The problem says to find dv dt when what is true? Well, at the time when the radius is 10, so when r is 10. So our equation, v equals 4/3 pi r cubed, is given to us. So the derivative would be dv dt equals 4 pi r squared dr dt. So now we have dr dt, we have r, we want to solve for dv dt. So it's actually already solved for dv dt. So 4 pi times r, which is 10, squared times dr dt, which is 0.04. So if I simplify here, 10 squared is 100, and I have 4. So 400 times 0.04. 0.04 is 4/100ths. So 400 times 0.04 gives us 16, right? Or if you write it as 4 pi times 100 times 4/100ths, the hundreds would reduce, giving you 16 pi. So 16 pi, and this is a volume, so it would be in cubic centimeters per second. So next, B, at the time when the volume of the sphere is 36 pi cubic centimeters, so V equals 36 pi centimeters cubed, what is the rate of increase of the area of a cross-section through the center of the sphere? Well, if you take the sphere and you go through the center and you make a cut, you have just created a circle, a two-dimensional thing. So we have a circle with a particular radius, and it has an area. Now, if the radius is changing, there is a dr dt, and the area is changing, so there is a dA dt. Now, once again, the volume of the sphere is 36 pi. So I can use volume in 4/3 pi r cubed to get my radius. So volume 36 pi equals 4/3 pi r cubed, so I can solve for r here. So if I multiply by 3, so 36 times 3 gives me 108 pi divided by 4 pi equals r cubed. So 108 divided by 4 gives us 27. Pi's reduce, so r cubed is 27, which means that r is 3. Now, it says what is the rate of increase of the area? So now we think we have a circle. So area of a circle is pi r squared. So dA dt would be 2 pi r dr dt. So now dA dt is what we want to know. So dA dt equals 2 pi r, which we just figured out was 3. And that means that dr dt, well, if you go all the way back up to the beginning, increasing at a constant rate of 0.04. So 2 times 3, 6 pi times 0.04, which is 4/100ths. So this would be 6 times 4, 24/100ths pi, or 0.24 pi. And this is an area, so it would be square centimeters per second. So now, part C. At the time when the volume and the radius of the sphere are increasing at the same numerical rate, what is the radius? Now this is interesting. Volume and radius are increasing at the same numerical rate. So what does that mean? That means that dV dt is equal to dr dt in terms of their number. We have to say numerical rate because they can't be at the same rate, because one is a cubic centimeters per second and one is a linear centimeters per second. So we have to say numerical rate. But anyway, at the time when this is true, what is the radius? So if dr dt is 0.04, that would mean that dV dt is 0.04. So if I take my volume, once again, 4/3 pi r cubed, and I get that dV dt would be, once again, 4 pi r squared dr dt, right? And if dV dt is 0.04 and dr dt is 0.04, then I can divide by both and I get 1 equals 4 pi r squared. So now, how do I solve for r? Divide by 4 pi, so I get r squared equals 1 over 4 pi, which means that r is 1 over the square root of 4 pi. Or you could write 1 over 2 root pi. And then obviously that would be centimeters. So we get 16 pi centimeters cubed per second, 0.24 pi centimeters squared per second, and 1 over 2 root pi centimeters. Hopefully you were able to follow these. If you need to go back, you can always review these on my website on the videos page.